and welcome to Applied Mathematics for Business, CQMS 1110. I am Dr. Pauline Fu. In this video, we'll talk about systems of linear equations / inequalities, part 2. Topic include systems of linear equations in 2 or 3 variables, solving system of equation using graphing, substitution, and elimination methods, applications of system of equations, revenue and cost functions. To give you an idea of what is systems of linear equations, let's look at this example. If 2 adult tickets and 1 adult ticket cost $32, and if 1 adult ticket and 3 child tickets cost $36, what is the price of each? Means what is the price of adult ticket? What is the price of a child ticket? Next. Okay. So let's look at the solution. Let's use X represent the price of adult ticket and use Y represent the price of child ticket. So based on this condition, 2 adult tickets and 1 child ticket is $32. So 2 adult ticket, 1 child ticket is $32. And then based on this condition, $36, 1 adult ticket and 3 child ticket is 36. So 1 adult, 3 child is 36. So this is example of systems of linear equations with 2 variables, X and Y. Generally, the format for system of linear equations is in this format. Ax plus by equal to h, cx plus dy equal to k. Our task is to solve x and y so that they satisfy both equations. There are 3 different methods for solving systems of equations. One is graphing, the other is substitution. Last one is elimination by addition. So let's solve this example using 3 different methods. Okay. This is the system of equations we get from the example, adult ticket, child ticket. Okay. So first, let's use the graphing method. Okay. So to solve for graphing method, you need to create a rectangular coordinate system. So this is x-axis and y-axis. And then you need to specify the unit. For example, this is 10, 20, 30, and 40. So this is 0, and this is 10. Okay, so 10, 20, 30, and 40. Okay, so now let's graph the first equation in this coordinate. To graph the first equation, let's say x equal to 0. When x equal to 0, y equal to 32. So this is 30, 32 may be here. Okay, y equal to 32 when x is 0. Next, you set y equal to 0, x equal to 16. So this is 10, 20, and 16 maybe here. Now you have 2 points, and you draw a straight line. Okay. So this is the first equation. And the second equation, when x equal to 0, y equal to 12. So this is 10, 12 maybe here, 12. When y equal to 0, x equal to 36. This is 30, 36 maybe here, because this is 30, okay? And now you draw another line between these 2 points, 30. And the intersection part, if you use the grid line, you have to see this, this point, okay? So you may get x equal to 12, y equal to 8. So this point is 12. This point is 8. So this is the graphic method. You get 12 and 8. So now let's do the second method, the substitution. So we call the first one is equation 1. The second is equation 2. From the second equation, we move 3y to the right-hand side. We get x equal to 36 minus 3y. This is from equation 2. And we call this equation 3. Now, substitute equation 3, plug equation 3 into equation 1. Equation 1 said 2x. When you say x, you use 36 minus 3y. And this is 2x plus y. Okay. So I have to change it. Okay. So this should be plus. Okay. This is 2x plus y equal to 32. And then you work a little bit algebra with this expression. So 72, okay, 2 multiplied by 36 minus 6y plus y equal to 32. And then collect like terms, okay, and move 72 to the other side. You have negative 5y equal to negative 72, positive 32. Okay. And continue, I will continue over here, and you get negative 5y equal to negative 40. So y equal to negative 40 divided by negative 5 is 8. The same as we get from graphical method. Okay, so once you get y equal to 8, you plug in this y into equation 3. So x equal to 36 minus 3 multiplied by x. X is 8. Okay, so 36 minus 24 equal to 12. So this is final solution for the second method. Okay, elimination. You eliminated one variable. Okay. So the third method is substitution. Okay. Actually, this is third method. Again, our starting point is these 2 equations. Okay. So for equation 2, both sides you multiply by 2. From equation 2, both sides multiply by 2. You get 2x plus 6y equal to 72. And we call this equation 3. And now use equation 3 minus equation 1. Left-hand side minus left-hand side, 2x cancelled out. And 6y minus y is left-hand side. You have 6y minus y. And right-hand side, 72 minus right-hand side, 32 equal to 40. Collect like term, you have 5y equal to 40. So y equal to 8. Once you get y equal to 8, you plug in this y into equation 2. You figure out the x, the same step as we do here. Okay, so this is the 3 different methods for solving system of equations in 2 variables. In general format, we have a system of equations with 2 variables. The example we give you have 1 solution. Okay, not all system of equations have 1 solution. Sometimes you have no solution. Under what condition you have no solution? Imagine if equation is represented by a straight line. This is xy coordinates. If the equation, one equation is this straight line, another equation is this straight line, as you can see, those 2 L1 line, L2 line are parallel to each other. If you have 2 straight lines parallel to each other, those 2 straight lines never intersect. This is the situation of no solution. They don't intersect. And the other solution could be infinitely many solutions. Under what condition you have infinitely many solutions? If you have 2 straight lines, okay, one line is here, another line is overlap with this one. They are repeated, okay? L1 overlap with L2. In this situation, you have infinitely many solutions. So far, the system of equation we talked about has a whole number or natural numbers as the, not natural number, integer as coefficients. But sometimes the coefficients are decimals. In that situation, you need to use appropriate factor to eliminate the decimal. For example, this is a system of equations with 2 variables, x and y, but the coefficients are in the format of decimal. Okay, so you need to eliminate decimal by, we call this equation 1, equation 2. If you have 1 decimal places, usually you multiply by 10. If you have 2 decimal places, you multiply by 100. This example have 1 decimal, so we multiply by 10 for equation 1. Okay, and you get this one here. Next, for equation 2, you multiply by 10, you get this equation. Once you are here, we did similar examples. You can use 3 different methods to solve this system of equations. Okay, this is one solution provided here. For this equation, every term in this equation multiply by 3, you get this equation. For this one, every term you multiply by 2, you get this equation. The purpose, you want to do subtraction. Okay, when you subtract these 2 equations, and you get this one, solve for x. Once you solve for x, you can plug in x into this equation, okay, and solve for y. It is here, okay. So this is when you have decimal places, you change the decimal places into the integer and follow the one of the three methods. So now let's look at the example of system of linear equations with two variables. The Clarkson Soccer League has set a budget of $3,840 for soccer balls. Highly quality game balls cost $36 each, while lower quality balls cost $20 each. If 116 balls are to be purchased, how many balls of each type can be purchased to exactly use up the budget amount? Okay. So let's see this question. Maybe I will do analyze here. Okay. So the question asks, how many balls each type can be purchased? So how many types we have? We have two types. One type is high quality game balls. Okay, we use X represent a number of high quality game balls. The other type is lower quality practice balls. How many balls we need here? We need Y. Okay, so we use X represent number of high quality balls. Y represent number of lower quality balls. So total, we need 160 balls. So high quality ball plus number of low quantity balls equal to 160. Okay. And each high quality balls is $36, and we have X. So total cost for high quality ball, 36X. And each low quality ball costs $20. We have Y, total cost for low quality, 20Y. Okay, the cost for high quality plus the cost for low quality equal to the total budget we have, $3,840. So we created systems of equations with two variables for this application. Once you are here, you can use one of the three methods we introduced: graphing, substitution, elimination. Okay. So this is the solutions. Okay, not solution, it is just give you the equation. So this is equation 1, and this is equation 2. Once you have this equation, you can use, maybe we can quickly solve it. From equation 1, we have X equal to 160 minus Y. We call this equation 3. Okay, and plug in this X into equation 2. So this is 36X. When you see X, you use equation 3, you use 160 minus Y, and plus copy down this 20Y equal to 3,840. And now you simplify this expression and then collect like terms. Okay, so 36 times 136 times 160. Maybe we can use the Excel to do it. to just do the calculation part, okay? We need to do 36 times 160. 36 times 160. The result is this, 5,760, okay? And where we are here, from current slide. My note disappeared, but I can quickly redo it. So where we are 36 multiplied by 160 minus y plus 20y equal to 3,840. Okay, so this times this, 5,760. Okay, and then minus 36y plus 20y equal to 3,840. Okay. And now collect these like terms. You have negative 12y equal to, move this item to the right hand side, and also you need to, it becomes negative 5,760, then positive 3,840. Okay. So you need to do that. So my result is negative 1,520. Okay. And now solve for y equal to, I'll double check this number, okay? Yeah, that is correct. So 1,520 divided by 16 equal to 95. Okay, y equal to 95. And once you have y equal to 95, plug in to equation 1, you get x equal to 160 minus 95. And you get x equal to 65. Okay. So this is the application. Okay. Last topic is the profit and revenue. What is the profit? Profit equal to the total revenue minus total cost. So profit, we use PFT. Profit equal to TR represent total revenue, TC total cost. Okay. Usually the revenue is money coming in, cost is money goes out. Sometimes we also write down total revenue equal to total cost plus profit. So total revenue equal to profit plus total cost. This is total cost. Total cost also has two parts. One is total variable cost. The other is the fixed cost. Okay. For the break-even point, it is when revenue equal to cost. Okay. When total revenue equal to total cost, you can solve for how many units you need to produce so that profit equal to 0. or total revenue equal to total cost. So let's look at this example. Maybe we can put this into a context. Suppose a manufacturer is producing a computer desk. The sale price for a computer desk is $40. The variable cost is $15. The fixed cost is $2,500. X is the number of computer desks produced. And the question asks you, how many computer desks need to be produced so that it is break even? So let's represent X is the number of computer desks we need to produce. So total revenue equal to 40 multiplied by X. Total cost equal to fixed cost plus variable cost. Fixed cost 2,500, variable cost 15 multiplied by X. Okay. At break-even point, you have total revenue equal to total cost. So you have 40X equal to 2,500 plus 15X. And solve for this X, you have X equal to 100. Okay. So when you produce 100 computer desks, total revenue equal to total cost. And the break-even point can also be expressed in dollar amount because you want to produce 100 computer desks. One computer desk sold for $40. You multiply by 40, you get 40,000. In summary, what we did in this lecture, we did system of linear equations in 2 variables. For 3 variables, we didn't give you the example. Please go to the related textbook. The idea for 3 variables is to change 3 variables to 2 variables because you can solve for 2 variables. And how do you change from 3 variables to 2 variables? Usually you do some subtractions and addition among the 3 equations so that you have 2 equations. Generally speaking, to solve system of equations for 2 variables, we can use graphing method, substitution method, and elimination method. Okay. We give you the example of system of equations. Finally, we talked about the revenue and the cost functions. That's all for today's lecture. Thank you for watching.